Hey there, this is Renner with Casne Engineering. Today we're going to be doing another demo with Casne CloudStream, and I'm going to show you how you can use Data Injectors to turn CloudStream into a real-time alarm system with text message alerts reading live data coming out of your Connect Data Services instance. So what are Data Injectors? Data Injectors are a feature in CloudStream that allow you to upload Python scripts and inject them directly into your data stream. There's no restrictions on the modules or packages that you can use. This means that you can use the full power of Python to manipulate your data in any way you want. In this demo, I'm going to show you how you can even use injectors to send data to places that CloudStream normally wouldn't support. So here's the layout for today's demo. We're going to start in Casne CloudStream, and first we're going to subscribe to data streams and connect data services. Then we're going to upload a data injector script, and this script is going to check if a value exceeds an alert limit. It's going to then send a request to Twilio. Twilio is an API service that can send a text message directly to my phone. Then we're going to capture each of these alert events within the event database in Connect Data Services. All right, let's hop right into it. This is the CloudStream System Control dashboard. I've already set up our service for today, but I'm going to show you how you would set this up. This service consists of three parts: a data source, an injector, and a data destination. The first thing that I did was set up a data source connection to connect data services. Establishing a connection to connect data services in CloudStream is very easy. First thing you need to do is give your data source a name. Then you need to enter your client ID and client secret for the instance you're connecting to. Finally, select the region that your instance is hosted in. Once you've entered all the information, you'll need to validate your connection, which will check to confirm that we can connect to your instance. Next, you'll need to enter the tenant ID for your instance. This will check for all namespaces inside of your instance, and then you can select the one that you want to work with. From there, you can select any streams. You can even select multiple streams at once, as long as they contain the same type ID. In this case, the tank that we're going to monitor, T100, has three different tags in Connect Data Services, one for pressure, temperature, and level. Once you've selected your streams, you can then perform transform operations on the data message. Here I've done one simple but important transformation that's available in CloudStream. By default, data from these tags is going to return a value with the property name of value. This makes it difficult to know what tag or what stream this data is actually coming from. What we can do to CloudStream is dynamically rewrite that from value to the name of the stream by using the shorthand method. In the override property name section, I've gone ahead and I've reassigned value the name of @stream_name, so CloudStream knows to dynamically look for the name of the stream and apply that to the outgoing data message. Once complete, you'll save your data source. Next, I'll talk about the destination. For this demo, anytime we have an alarm, we want to send that alarm back to the event store Connect Data Services. Connecting to the Connect Data Services event database is very similar to connecting to their stream database. As before, we'll enter a name for our destination, our client ID, client secret, and select our region. Then, after entering your tenant ID, we'll indicate that we want to search for events in the namespace that we select. This brings up the Events tab, and we can select any number of different event types that we want to send data to. You can also create event types in CloudStream. To do this, you'll just need to name the event type, select an authorization tag, and then you can add event type attributes in addition to the default attributes for any event. Once you have an event selected, in this case, I've created a custom event for tank alarm that includes things like tag ID, operator name, and then a Boolean that can indicate if the operator was sent a text message alarm. We'll select it and save our data source. Now all we need to do is set up the injector. To make injectors in CloudStream, you just start off by pressing the New Injector button. You'll need to enter an injector name, a script name if you want to reuse the script against multiple injectors, and then enter your code block. You can also upload a Python file directly if you've already written a script. The last thing that you can do is set up variables. Variables in CloudStream are held in memory. This means that every time the script runs, you can access the previous value that this variable stored. This can be very useful for storing things like totalizers or other values that need to be persisted every single time you get a new piece of data from your data source. For this demo, I've already created a data injector. I'll walk you through the script that I'm using and show you what it's going to do to give you an idea of the power that data injectors have in CloudStream. This is the script I'm going to be using for this demo. I've removed some information, such as my Twilio account information and phone numbers. You could use this same script, just replacing the information that's been removed with your own account information. The first thing that I do is import the libraries that we're going to need to use. This includes the Twilio API library and the UUID library, which we'll use later. Then I initialize my variables and create some functions that will help us send messages to the Twilio API. For this demo, I've added the control limits into the script. However, if your control limits already exist in your data source, meaning they're either part of the data stream, or perhaps they're in a PyAF attribute and you're pulling from Py instead of Connect, you could use those values instead of writing them directly into the script. Finally, we get to the meat of our script that will actually execute most of the code. Data is always sent as a library called data. When we look through each item within this library, we're going to check, is it above our high limit or is it below our low limit? If so, we'll send an alert and let the script know that an alert was sent. If the alert was not sent, we're going to clear the data. This is going to terminate the CloudStream service at this point, so it will not create an event if one was not needed within Connect Data Services event database. If an alert was sent, we're going to rewrite the data within the data library in a way which is compatible with our event schema that we configured for our data destination. After you've set up your source, injector, and destination, it's time to create a CloudStream service. This is done by clicking on the New Service button, entering a service name, selecting your data source, any injectors that you would like to add, and your destination. Once you press Create New Service, the service will be created and immediately start running. I've already created this service and named it T100 Monitoring. We can now monitor this service and view the data as it passes through CloudStream. We can both trend it to see how many data points are flowing through at any given time, and we can watch for live messages by clicking on the magnifying glass. Next, what I'll do is enter some values into Connect Data Services. Then we can monitor how this works in real time. Here I am in Connect Data Services Sequential Data Store. This is the screen for adding an event manually to one of your data streams. In this case, we're going to be adding an event to the T100.level. If you recall from our script, we set the high value for T100.level to 90 and the low value for 10. We can first start by exceeding our high limit. Let's enter a value of 95 into the system. This should produce an event in CloudStream because we exceeded our limit. CloudStream is currently set to check for new data every 10 seconds. So within 10 seconds, we should see a new data point within our system. Here we can see the outgoing data. It's indicated that the tag name that had an excursion was T-level 100, the operator is me, and I've been notified. Sure enough, I just received a text message on my phone indicating that the alert has been exceeded. This text message reads, Alert, T100.level is above the limit of 90. Current value 95. This incident has been logged as an event in Connect Data Services. Next, let's check the lower limit. Let's go ahead and add a value of 0. Once again, we'll need to wait up to 10 seconds for the value to be read by CloudStream. As expected, we have another event created, and I've received a second text message. This text message reads, Alert, T100.level is below the limit of 10. Current value 0. This incident has been logged as an event in Connect Data Services. Finally, let's confirm that when we have an event that doesn't exceed a limit, that nothing is created and the event is terminated. In this case, let's create a value of 50. Here we'll wait up to 10 seconds, but we would not expect to see any event because the outgoing event would be terminated by our script by setting the data library to null. As expected, we don't see any event coming through. This is the GraphQL console for Connect Data Services. Here I'm requesting the operator name, operator notified, tag name, and start time properties for any events from our tank. I'll send the request and I can see both of the events that were created today. The operator is notified and the tag name for the event is listed along with the time which the event occurred. If we wanted additional information, such as the value at the time the limit was exceeded, the limit itself that was exceeded, or an indication of whether or not this tank is still in an alarm state, we could add those by modifying our event to data services and updating our data injector as well. There's really no limits to how we can use data injectors to modify and transform our data in CloudStream. We can use it to do things that we normally couldn't, like send a text message to our phones, or to terminate our service early if the data doesn't meet a criteria that's required for it to send to its endpoint. We could also implement things like AI or machine learning, which will be shown in future demos. Thank you so much. My name is Renner. You've been watching another demo by Casne CloudStream. For more information, please email cloudstream@casne.com.